In many cases, measuring the physical characteristics of a structure changes the structure itself. But what if we could measure these properties without actually touching it? In the case of vibrations and acoustics, this is called non-contact testing or non-intrusive testing. Determining the natural frequencies and mode shapes of complex structures like those of blade discs and jet engines first requires us to harmonically excite the structure. In other words, it requires us to introduce a vibration so we can measure the force response and then determine the physical characteristics we mentioned earlier. My name is Lucio Cota, a senior studying mechanical engineering at the University of Arizona. As part of the Summer Research Opportunity Program at the University of Michigan, I worked alongside Dr. Bogdan Epureanu to develop a system for virtually non-contact excitation. Although speaker systems proved to be an effective non-contact way of exciting structures, acoustic excitation becomes cumbersome and impractical as they are pushed to the high frequency range. Our research offers a new device, which we call the Excitation Clamp, is able to excite at higher frequencies and deliver higher forces than contemporary acoustic methods. The device actually comes into direct mechanical contact with the structure, but is able to still achieve the same non-contact effect as acoustic excitation by the use of piezoelectric actuators that work out of phase to excite the structure. The system also features thin film force sensors to measure the applied forcing. Okay, so now we have our experimental setup, and basically it goes tooth, sensor, test specimen, sensor, tooth. And right now we're just testing a aluminum bar, and we are supplying it 20 kilohertz with 5 volts, and you can see on the oscilloscope we have a nice waveform with channel 1 being the top sensor, channel 2 being the bottom, and channel 3 is our input. So in the end, the device shows a lot of promise, and with a little bit more research, this could turn into a fully automated, more efficient, non-intrusive method to harmonically excite complex structures. Hope you enjoyed.